Hey folks, so this video is going to be a culmination of all the things we've worked on in all the previous videos, but you don't actually have to have seen any of the previous videos to follow this because I'm mainly just trying to make this an excuse to show you intermediate Python concepts in a practical, like this is real world example sort of thing. The whole series is basically that, where we're making a Dropbox clone that is peer-to-peer on a local network, and we've got creating these caches of all the files that we want to share, and we spent the last many videos, like 5 I think, on creating the networking stuff. So we've got a whole peer-to-peer network that we've written in the last 5 videos, and the last 2 were spent on making sure that that was locked down and secure, and we even reached HIPAA compliance for our privacy and security. But now we got to tie that the whole networking file back into our main program. And that's going to provide a lot of interesting opportunities for me to show you real world examples of some very intermediate Python concepts. So I've got a whole bunch of to-dos that I need to did. And the first one here is that I need to save the remote connections URI. When a peer connects to another peer, it doesn't actually save on the server side of that connection the URI. So when they're sending status updates to one another and they're saying, hey, these are all the other peers that I have, and here are all the files that I have. If the server was, if one of the peers was the server in that relationship, then it didn't save a URI. So we can quickly and easily do that thanks to the comprehensive WebSocket framework that we're using. We just go to the remote address, and this is a tuple, so we want the 0th item of that. And we have done the to-do. So we can now move on to the next thing, which is making our whole port scanning thing really asynchronous. Because right now, it's got the async here, and it will not break all of our other background processes or the UI, because we've got this await at the end of our loop. So every time it's going through and trying to connect to somebody, it backs out and says, okay, I'm sleeping for just a second here. I'm actually sleeping for 0 seconds here, which gives any other background process that needs to jump in an opportunity to do so. But this is really slow. We can supercharge this by using batch tasks. So in order to do that, first we're going to need to make a single simple function that we're going to use as that batch task. So have a simple async connect here. And we're going to steal most of this code, so we just need to grab it like this. And we'll plug it in here, I guess. And I need to make sure I do this next here. So all this function is doing is taking a URI, which is like this WS IP and our port. And we're creating a client handler, which is a subclass of the connection handler, which is the whole big thing that we're stuffing all our peer-to-peer stuff inside of. And once we have that connection object, we can try to log in. And if it's successful, the state of that will be set to connected. And then we know, okay, well, this is good. We need to add this to our connections, which is a really important list where we're keeping track of all the various peers that we have. And then we're spooling up a new task that's taking the listener method of that specific connection and saying, hey, listen for anything else that happens on this connection that we have. So that's really simply put together here. This is a function now that we can use in a list of these things. I'll show you here. So I'm going to create a list called the task list. And I'm going to change the I. This is the beginning IP that we were starting at. As we were debugging, or just using it as we were trying to limit the range. In this case though, since I'm going to make this super fast, we can do the whole range from 1 to 255. And I'm going to move this I plus to the bottom of this. So now we go through this process of just stuffing our IP range, which we figure out up here, dot I, into this and create the URI. And now we can append to our task list, append a new connect function that we just created up here with this URI to our task list. Now, it's not going to actually run that we're just stuffing this function into a list. And now we can check, okay, if the modulo of if you divide I by 5 and you get a 0, that means that we're on a multiple of 5. So that means we've got 5 items in the task list, and we should now run those. And we can easily do that by doing an await async IO gather. And here I'm going to stuff the list in like this, but this isn't actually going to be useful because this gather thing, it wants a whole bunch of different coroutines, and I just gave it a list, and that's not what it wants. So we can unpack that list by doing a star in front of this, and that's just a simple way to unpack any list anywhere. You put a star in front of it, and it's telling it, okay, just take everything that's in this and explode that. And it's kind of rare to use the asterisk at all in Python. Another example would be if we were trying to take a dictionary and unpack that, it would be 2 stars. But and it's complaining because it knows that it can't do that to a list. But in this case, we're saying take all of these 5 connect functions that I've created and gather them all together in our async IO loop that's already running. It's just going to automatically run them all. And I can show you that. And I should also make sure that I empty the task list. So let me spool up our debugging thing here. And we should see client now. Yeah, he's trying to hit all 5 at once, basically. And you see that sometimes they come in different orders. So like 11 came before 15, and 20 is coming after 17 and before 16. So it's doing all this much faster now because it's not waiting for one particular connection to be timed out or refused. It's going through and hitting 5 and trying to move through all this really fast. Trying to think if there's any place we need to put any more sleeps. No, that looks good. This is another really important intermediate Python concept. Get rid of your debugging print lines because, man, your program, like 6 months down the line, you're looking at the output of your program, you're seeing all these weird print statements, and you're like, what? I don't even know what this is telling me. And you go to search your source codes for print, and now you've got all your debug things, and they're just getting in the way. So as you're at this stage of the development process, look for these print debug statements and get rid of them. So we've now made our already asynchronous port scanner extra supercharged asynchronous. All right, so let's make sure that we're not duplicating any connections by trying to, like, if we've got a server client here, the server doesn't try to connect to a client that's connected to it already. And we also want to make sure that we're not trying to connect to ourselves. So let's test for that first. Say if URI equals, and here we're going to have to construct what our own URI must be, which is RIP at port 11111. And if it is, then just return. Don't do anything here. And for the next one, we're going to actually have to go through every single connection that we have in our connections. So for connection in connections, if URI equals connections URI, then we know that's a duplicate, and we'll just return out of that. So it never gets to any of this part, and that'll prevent any duplicate connection handler objects. All right, it's another thing off the list. So now that we've got this simple function for our connect that has a dupe checker here, and we're going to be getting useful information from the status updates, we want to be able to now connect to any peers that we're not already connected to. So let's go up to where we're getting the status update message and start saving some of the information that we're getting in this status update. So in this case, we're going to need to be saving the shares and the peers. So let's add this to our class at the top here. All the way at the top. There we go. Our shares. Actually, we'll make that an empty list. And peers. So now here in the listener method of this connection, we can start to save this. So we'll save the shares as data shares. And we should also save the peers now, which is sent as connections. And And that's all the data we should need to save at this point. So we've got that done. But now we can attempt to connect to any peers that we might have missed. Like maybe they came up after we did our port scanning. But if you got a little tingle in the back of your head, it's telling you that you're over-engineering. And we're trying to solve a problem that we've already solved with one way. Now we're just trying to solve it extra hard, and that's bad. That's terrible. I'm going to proceed to make this terrible mistake of over-engineering just so I can show you what happens when you do that, because it's one of the things I struggled the most with when I was learning to code, was to not over-engineer things, because I thought I was being clever. So let's go through that folly of being clever here. So for peer in self peers, let's await connect to that peer's URI. So because our connect thing is looking for any dupes, we know that we're not going to accidentally connect to ourselves, and we're not going to connect to anybody else that's we're already connected to with. So what could go wrong? We'll see that later on in this video. We need to make sure that the shares thing that we're sending now in our status update is correct. So I was throwing in some kind of junk data here just for the purposes of getting the networking stuff working. Let's go in and actually add in the stuff that we're going to need. So we're going to need the ID of the share, because I don't want to rely on file names. And we're also going to need the cache time, which is the share cache, the last object in the cache list, cache time. And we're going to use that for checking to see if our version of a cached file is newer than a remote version of a cached file. Yeah, we got cached time and ID. So now we can jump over to back in that status listener section here. Now that we've got the shares, we can go through and compare all of our shares against all of their shares and see if there's any files that we're interested in, and if there's been any changes between those files and our own. So I guess we're just going to go through this for share in self shares. I'm going to use the database rather than the way that we save the shares to a we save the shares as a kind of object here in the base of our program, but we're doing that for the UI. In this case, it's going to be smarter to just access the database directly. So I'm going to say wanted equals dripbox db shares find one, and that is the way that you would do this in PyMongo, or in our instance, we're using TinyMongo. So if this query looks weird to you, you should go back and watch the TinyMongo thing, because it's pretty amazing. So we're just going to look for an object that is of this specific shares ID. And because I'm using the find one, it's either going to return the thing we want, or it's going to return none. So we can do a simple test. If this is wanted, well, then this is definitely a file that we're interested in, because it's saved in our own database of shares. So now we can do comparisons on the remote connections share of this and our own version of this. In our file management, when we're checking our own local files for any changes, the first thing that we do is check the cache modified date, because it's a really computationally easy thing to ask a file when was the last time you were modified. It's much more computationally expensive to go through the whole file and build up a hash of that. So first it checks if you've changed, and if you've changed, then okay, now I need to check the hash to see if you've really changed, because sometimes the modified date will change even though the file itself won't change. So we've got the two checks there. In this case though, the first thing that we can check to see if there's any kind of discrepancy is the hash itself. So that's what we should do first, is if the wanted cache last item of that cache list cache hash does not equal the shares. And remember, this is much more simplified. We don't have to go through the whole list of things. It's going to have the cache hash. It's telling us this is the most recent cache that I have. So if these don't match, then we know that there's some difference between these two. Now we need to figure out if our version is newer than the remote machine's version. So if wanted cache time, and we're using cache time instead of cache modified because the modified will probably be slightly different between machines, but this cache time is something that we're making up and we're saving across our database, so we're always going to have the same cache time across all machines, whereas the modified dates, that's looking at the files themselves, there's likely to be a lot of discrepancies. So if this time is less than the shares cache time, then we know that ours is older than theirs and we need to ask for it. But this comparison isn't going to work because this is coming through as a string and this is a datetime object. So we need to convert this into a datetime object to make this comparison actually happen. So we'll do a datetime string p time, and here we stuff in the thing that we're trying to convert into a datetime object, and it is year hyphen month hyphen day hour colon minute and second, and it's not doing microseconds, so we don't have to worry about that. So this is now a comparison that will work, and now if we get to this step, we know that, okay, our hash is different, our time is older than the remote versions, so we want this new version. So we need to send a await self send of op type request, and now we got to provide all of the relevant information that this is going to need. And right now it's not looking for the ID, but that's really the most relevant information that we can send. Is this is the ID of the thing that I want you to send me. So we could do a test on the file name. Nah, the IDs will be unique across everything, because these IDs are huge. There's no way this huge number is ever going to accidentally collide. So we can be confident that the ID is something we can reliably expect not to be a duplicate. Whereas with file names, we could have duplicates of things easily. But we will still say the file name just so we can have it print out here that it's requesting the file name. So now let's make sure that we use that correctly here. We'll just do the if. Yeah. We now need to make sure that the request handler here, so the way this is working, right, is this status checker figured out, okay, I need to request this file. So now we send this request, and the receiver says, okay, I've got this file that you're requesting. And here is its file name, and let's also put the ID in this. We're probably gonna need a lot of we're probably gonna have to do something with the date time things because of the way that we're sending this, but I'll deal with that later. And I'll just give the cache time equals share cache most recent cache time and stuff that in here. And I'm trying to keep everything in order. It's really, really helpful if you keep things in order. If you assign it here, use it here in the same way. The path we're going to use, we don't need to send that to them. That looks good. I think we did all that right. All right. Another to-do done. So now that we've changed the way that the request op type handler inside a listener is sending information, we need to make sure that the op type handler for sending is correctly using this information. So let's throw in our data ID and our cache time here now as arguments to the file receive method. And you see it's complaining now because it's not expecting these extra arguments, but we're going to add those now. And we're using underscore ID instead of just ID because ID is a thing in Python, and that's going to be confusing. So we're saying this is a private ID thing and not the ID thing you're thinking of. So we're now using all of the things that we're aware of. We should probably do a little check here just to make sure that this is a thing that we want. And we're going to need to have a instance of our database object anyhow. So let's grab that. So db shares, find one that's got the same ID that we're being sent. And if share receive the file. And now that we are going through this process of creating the paths to save we're saving it to a cache directory, not directly to wherever we're going to be using this file on our computer, but a specifically made place for us to safely start dumping all this data into until we're ready to use it. Once it goes through this whole process, and it is breaking it up into chunks of 8,192 bytes, and then just reconstructing it all. And now we need to make sure that we've downloaded it correctly so we can compare the hash of our local cache to whatever cache hash the remote server said that it should be. So let's do that using the get hash function from our file management. So if await get hash, and here it will be the OS path join of the place that we just saved it to, which is the cache path and the file name joined together. If this does not equal the cache hash that the remote machine told us this should be, then we've got a problem, and we should be notified about that. Download of this file name from this host was corrupt. Now, we don't really have to do anything to handle for that because of the way that we've structured this. The status updates are just constantly coming back and forth, and that's where we started this whole process. So in order to restart this process, all we need to do is undo everything that we've done here. So let's just delete anything we downloaded and this path that we created. And we can do that all in one simple step using the shutil rm tree. We import shutil here, shell util, which has got this great remove tree function that'll delete from a folder everything past it. So all the recursive folders inside of that folder and any files, they're all just immediately gone. You gotta be a little careful with this because it will just absolutely delete anything that the user running this program can delete. So in this case, we're just trying to get rid of our cache path. And that way, the next time it goes through the status update and it sees, oh, hey, this is a file I want, it'll go through and start over the whole process of creating the whole the cache directory and trying the download again. And maybe we would want to put in some sort of a fail safe here of trying to keep track of how many errors we've had with a server and stop trying anything if we keep on running into that. But right now, I'm just going to keep moving here because we've got a lot more to do here. So if we get past this, because we're going to just, how do we back out of this gracefully? I guess if we move the states, because we don't want to move on to saving the file if that is the case. We just want to return out of this. So yeah, I'll move the self state connected, because this is really important. We've got to keep track of our states in any kind of networking stuff. Now, it only switches into the transfer state when it is actually going to receive something, and it switches back to connected, which is our general. It's okay to send me status updates and things as soon as the file is finished downloading, and it doesn't care about this. So now we can just return out of this. So now if we get to this stage, we know that we've downloaded the file and we know that the file has the same hash as we're expecting. So we want to move this to wherever our computer is actually using this file. And we'll use the shell-util package and its copy-to method, which is, it tries to preserve more of the data about the file, like the owner and things like that. So we'll just use that. OS path join, and this is going to be our cache place. So it's just the cache path and the file name. And we're going to move this to wherever we've saved in the database that we're grabbing and saving this file from, which we saved as the share path. For every single file, we've got a share path that'll include the file name. So we don't have to do any OS path join stuff. We just say, wherever you've saved this thing, let's copy this to it. We'll do share path. Now, this next trick is such a pain in the ass, but it's really worthwhile because we can actually change the modified date of a file. And it's going to be a nightmare, but it's going to be worth it for any programs that are using the files that we're sharing back and forth across our network. If they care about the modified date of a file, we're going to have them covered because we're going to have it as close to as accurate as possible across all of our machines. So they all have the same modified time for a file. And we're going to need to convert some things here first. So this cache time we know is a string. This cache modified is a timestamp. So we're going to need to convert those both into usable datetime objects here. I'm just going to write over the cache time with a simple datetime string p time of cache time. And once again, it's the year dash month dash day, hour, minute, second. And for the modified time, that is going to be a datetime from timestamp of cache modified. Okay, so we've converted this into useful Python data types that we can now do stuff with. The next thing we need to do is, this is the mod date. We need to create the mod time, and the mod time is a time object. So we're going to time make time, and here I need to import the time, not from the datetime.time, but the time library here. So time make time, we give it the mod date, but we give it as a tuple, which is really weird. And it's going to get even weirder now because the cache modified, here, let me just bring up a console and I'll show you. Now is datetime UTC now. So here's what a time tuple looks like. It shows all this. This cache modified is a timestamp though. So it's like this, where it's got the seconds since the Unix epoch and the microseconds of that, or the picoseconds. It's some minute portion of time that's right here. And this minute portion of time here is going to screw up this whole process of trying to set the modified times on files because it's going to be ignored. So if we've got a different modified time from what we actually set in our database, it's going to immediately screw up. So we need to actually convert this first by rounding this float and then turning it back into a float. So what we're basically doing with this process here is timestamp equals now timestamp. We're rounding that. So we're getting rid of anything after that, but then we need to convert it back into a float. And now it's usable from this, from timestamp, which is expecting a float as the input. So I'm losing my mind trying to explain this thing. We need to now take that object that has none of the microseconds involved and change that into a time object. And now we can use that using the OSUTime, which is going to take the path of wherever we just copied this to, which is the share path. And here it wants a tuple of mod time. A tuple is like a list, but it's not quite a list. So the first, or the 0th item of this tuple is going to be the activation time, and the second one is going to be the actual modification time. And you can't just do one or the other. You got to do both. So we got to stuff this into these UTime thing like this. Like this is the way it's done. It's a massive pain in the ass, but we did it. Like this is how you change this OSUTime thing, is how you change the modified date of any file on your computer. So with that done, now we can save all of this to our database to update it and say that, okay, now we've got the latest version in our cache. So let's create the new cache object, which is going to be a little dictionary here that's going to have the cache path, which is whatever that was, the cache time, and here I'm going to stuff in the date time object that we created here, and not a string. Like this is important because this came across the network as a string, and we're saving it as a datetime object inside of our database, which is helpfully converted using TinyMongo into a tiny date, which is automatically converted back into a Pythonic datetime object. And the cache modified is going to be actually saved as a timestamp. So we're going to take the mod date and get the timestamp from that. We're not going to take the cache modified because we did all of this stuff and we saved the file with this. So if we put in the wrong mod date, we're going to have immediate, like, oh, hey, this modified date's wrong. I'm going to have to check the hash and all this. So, we don't want that. So now we've got the cache hash, which we have verified as already being correct. And if we were doing this in with PyMongo, with like a real big Mongo cluster, we could just use the add to set function that will let us change an item in a list. But because we're using TinyMongo, we don't have add to set. We need to do a weird juggling act. So we're going to create a cache list of the shares cache. So we're just taking the whole list that's in there and calling it this now. And we need to make sure that there's only a maximum of one other object in there because we were only keeping 2 copies of a file in our cache. So if there's any more than that, we're going to need to remove it. So if the length of the cache list is greater than 1, we need to pop the old one. So old cache equals cache list pop. So this will grab the first item of the list, and that happens to be the oldest. And so now the cache list will only have 1 item because it should never ever be able to get more than 2. And while we're at it, let's remember to remove the old file. Oh shit! Util rm tree, the old cache path. So any old caches are getting destroyed here. Now we can take this cache list and append to it this new cache that we just created. And now we're finally at the point where we can just add this easily to the database. So Dripbox DB shares update 1 ID of whatever the ID was. And we can now just use the set on the cache field and just stuff the whole cache list in there. And it has now been updated. We should probably reload the shares here. Here, we're just grabbing everything and stuffing it into the shares, because we're going to be using that all over the place. We want to make sure that that is up to date whenever we make a change to the database. We did this. We didn't actually do the updating of the UI and the refresh stuff. We're going to do that in the next video when we start to finalize the UI. I think this is another to-do that is done. While I was doing that, I thought about this, and like, we're doing all this stuff to make sure that the mod time is correct and we don't run into the problem of our database saying that our mod time should be something, and then our local file checker says, wait, hold on a second. If the modified time is different, then I got to go through this whole hashing process. But we haven't actually added something to update the database to say, oh, wait, this file hasn't changed. Like, if there's no change, the modify date was just changed. Let's add that here. So let's make sure that we don't keep on saying, hey, this file changed, this file changed. Let's add an else here. So if the file didn't actually change, we're going to update it by basically doing all the stuff that we just did right here. I'm just going to copy all this, because we gotta copy the whole. We got to do this whole nonsense again. We don't have to actually pop anything, but we're going to have to create this whole cache list and append and then update. So yeah, I'll just grab this, delete the part that's deleting stuff, and we'll grab the shares latest cache entry, and its latest cache time. And here the modified time is whatever discrepancy we're getting. So let's just get the latest modified time of the file. And the hash, yeah, we don't need to rehash it. So we'll just grab that. We'll just say that whatever the last item of this cache list, let's update that to be this cache that we've created. And that should be it. We're just setting the cache to this new, oh shit, to this new cache list. Shit, I made the mistake over here too, didn't I? Oh, I'm glad I did that. All right. Good. I'm really confusing the hell out of myself with all these cache things. All right. We're updating the database and we're reloading the dripbox.shares. All right, that is done. So now we're actually at the stage where we can actually combine this whole networking thing with the rest of our application. So let's go through that process here. The first thing we need to do is we put the start server thing inside of the main clause, and there's no reason to do that. So let's move that right above it. Whenever the networking thing is imported, it's going to create this start server alias, I think is the right term for that. And now we need to import this and a whole bunch of other stuff into our main thing. So from Dripbox networking, import the port scanner and the start, or the status update and the start server. And we need to add these to our whole main async IO loop. So when the background is running and the UI is running and the local file checking is running, we're also going to do a port scanning and a status update and the start server. And because this is an alias, not a function itself, we don't add the parens at the end of this. So we're adding all of these things to our await, which is our main thing that we run until complete on all these. So this should work. I'm now going to set this up on a couple of other laptops so that we can test this out and see if all the things that we've done are actually working. All right, this has been a massive pain in the ass trying to set up, but I think it's going to be highly informative if it works. I'm going to change the start range for this machine just for these purposes of debugging. I'm changing it from 1 to 141 so that as it starts its port scanning on the IP range, it's only going to be able to find one laptop at MSETI at 146, and it won't be able to find BESS because BESS is way too low on the IP range that this machine is even looking for. So that when we connect to MSETI, we'll learn about BESS in the status update, and hopefully then I'll be able to show you why that was a dumb idea. So let's see what happens. Okay, the interface came up. We've got no errors, and we connected, and we're okay. So another thing I wanted to test here was the actual file sending. So the grab me is slightly different on this machine from and the one on MSETI, and as you see, the other stuff was flying through in between all the get chunks. You see it's trying to make all these connections, and it's getting a status update from MSETI actually or BESS in there. So see, we are getting status updates from BESS. So we did connect to BESS, and you'll see right here the problem that I was trying to allude to before, where we've actually established two connections. See, this is BESS telling us BESS's status, and he's saying that I'm connected to Thoth, and I'm connected to Thoth and MSETI. And that doesn't make any sense. Well, how did that happen? Because we did all the things to make sure that we wouldn't have any duplicate connections. But you see here, when our update status, that's our way of saying to files, or file thing just updated, so it distracted me. This is our way of saying to ourselves here, and this update says how many connections do we think we have, and right now we think we have 3 connections, even though we're only connected to 2 laptops. So that's confusing. Why is it doing that? In fact, I can show you if I close this connection on MSETI here. I see we got a connection closed from MSETI, and next time it does an update status, it will show 2, and it will only be BESS status right now. BESS thinks that he's only connected to Thoth, and our update status is also saying that we've only got 2 connections because right now we're telling BESS that we're connected to BESS and BESS. So how did this happen if we've got all that error checking? Like we're trying to make sure that we're not duplicating ourselves, we're not duplicating existing connections. In the fraction of a second that both machines got the same status update from MSETI, both machines said, here's a new connection, and they slammed each other before we got to this portion. So this is one of those things where I'm over-engineering the problem. Like, I've already got a good solution. As long as I just leave this and let this scan through and expect all the other clients to just, whenever they start up, they're going to scan through all the IPs. They are definitely going to find each other. There's no reason to overcomplicate this. And like, this is contrived, but I wanted to show you that you can really easily overthink these things and get in your own headspace and thinking, I'm so goddamn clever, I'm doing all kinds of amazing things, I'm going to make this even better, but you actually end up making it a mess of things. I guess another thing to point out here was that we didn't get any errors after all the file downloading stuff happened. And the fact that it popped up here, it did like a refresh thing, indicates to me that it did that successfully without any problems. Like, yeah, we got all that. Let me check the local file here. It should be, yeah, this is from many days ago at 5:33 p.m. So we did successfully change the modified date too. I'm very, very pleased. It worked. In the next video, we're going to really finalize this. We're going to take the UI and clean it up, and we're going to add in some more features that are missing in the UI and do some more optimization stuff. But I think that's definitely enough for one video. Thank you very much to my Patreon patrons. Take it easy, folks.